Properties of functions. We're going to start with even and odd functions. A function is called an even function if for every input of x, f of x equals f of negative x. The graph of an even function is symmetric with respect about the y-axis. So a function is called an odd function if for every input of x, f of x equals negative f of negative x. The graph of an odd function is symmetric about the origin. Okay, so we're going to look at these problems below and use this definition to try to determine if they're odd, even, or neither. Okay, and that's what this says here. Determine algebraically whether each function is even or odd. So that's what we're going to do here. But before I get started, I just want to take a look at one thing here. And it's this equation here. Now, when I look at that equation, the result we get immediately is not necessarily this if it's an odd function. So what I'm going to do is I'm just going to take that equation there and divide them both by a -1. And then when I do that, I'm actually going to get the equation negative f of x equals f of negative x. And that's the actual immediate result we get when we're actually trying to find if it's odd, or the result if it's odd. So we're going to try to find this result. And then when we find that result, we can say it's odd. Okay. And I just wanted you to see that these two here were equivalent. All right, so let's get started with this first one then. It says f of x equals 2x to the 4th minus x squared. So looking at the way we start any of these, we're going to put a negative x in for x, for every one of them, when we're trying to determine algebraically if a function is even, odd, or neither. So I'm just going to take f of negative x. And that means I'm going to plug in negative x wherever I see x. So that's going to be 2, parenthesis, negative x to the 4th, minus negative x squared. So then that's going to equal 2 times, now think about this negative x to the 4th power. That's an even power here. So that means I'm going to get a negative times a negative times a negative times a negative. And that is going to result in a positive. So that means I'm going to get x to the 4th. And in a similar way, I'm going to take care of this one the same way because it's also even. So it's going to be a negative times a negative, and a negative times a negative is positive. So this is actually going to result in an x to the, not x to the 4th, but an x squared. And if you look at this algebraic expression that we ended up with, you realize it's the one we started with. It's actually f of x. So this actually equals f of x. And since it equals f of x, this is really what we have. And I'm just going to rewrite it so you can see it. So we really have f of x equals f of negative x. And if I look at the top here, is that one of my two results that I should end up with? And if you look at the first one, that is f of x equals f of negative x. So that would tell me that this is an even function. And it also tells me that it's symmetric about the y-axis. So I would write implies f is an even function, which implies f is symmetric about the y-axis. So next problem. So that means we're going to take f of negative x, and that equals the cube root of negative x. So if we understand cube roots at all, remember this is an odd index here. So that means if, let's say that was -1, that would be cube root of -1 times, it would actually, the cube root of -1 would be -1 times -1 times -1, which would still be -1. So in a sense, the negative will always come out because it's an odd function, and when do we have a negative? So this is actually going to be the negative cube root of x. Okay, so then this is actually equal to the negative f of x. So if I took the negative away, it would be exactly this function here. So that tells me it's this condition here. It's for the second one, because that's f of negative x equals negative f of x. And that's what we resulted here. So that tells me then that f is an odd function. And it also tells me further that f is symmetric about the origin. So now let's look at the last one here. This is f of x equals x plus the absolute value of x. So that means we're going to start with the f of negative x. And that equals negative x plus absolute value of negative x. So now this is negative x and plus, if I take the absolute value of any number, positive or negative, it's going to result in a positive. So this would be equivalent to absolute value of x. And it doesn't meet my first condition. This does not equal f of x. So it takes this one out of the running there. And then what we look for next is it going to be negative f of x. So in order to figure that one out, we would have to pull a negative out of this function here. Okay, so I'm going to pull a negative out. So this would be negative x, and then here that would now be a minus, because that's a plus, absolute value of x, which this part right here does not match f of x, so it's neither negative f of x or f of x. So this tells me then that since it doesn't meet either this condition here or this condition down here, that it's neither. So implies neither. Done.